Okay, in our previous units, we've been talking a lot about parabolas, about factored form, vertex form, standard form, and we're going to start putting it all together today. The first lesson in Unit 6 is called Maxima and Minima. Don't be confused by those words. Maxima is just the plural for maximum, and minima is just the plural form of minimum. So what we're doing here is we're going to be looking for the maximum point on a parabola or the minimum point on a parabola. That's the maximum or the minimum, and we do that by finding the vertex of the parabola. But the challenge is we don't always get our quadratic equation in vertex form. So the goal for today is to get from standard form to vertex form. So we want to get from standard form to vertex form. So in writing the general equations, we're going to be starting with something like y equals ax squared plus bx plus c. And we want to get to, we're going to use our algebra skills and a special strategy to get to y equals ax minus h squared plus k. From standard form to vertex form. Well, how do we do this? If we look at this vertex form, we see this x minus h squared. This is called the square. It's a squared binomial. So this is a square binomial. Squared binomial. You'll notice that that squared binomial is not immediately evident when we look at standard form. So what we're going to need to do is create a squared binomial by a strategy that's called completing the square. Once we complete the square, we're able to rearrange our equation into vertex form. Once it's in vertex form, we can identify easily the minimum or the maximum point on a parabola. Here is a demonstration of completing the square using algebra tiles. So this is the goal. This is the goal of what we're doing today. And I'm going to demonstrate it using algebra tiles. So we have the quadratic equation y equals x squared plus 6x plus 5. Does anyone here know how to draw that just by looking at it?
There's the equation.
The answer is no, you don't know how to draw it. So what do we need to do?
Convert it.
Convert it to vertex form.
You can
Okay?
just do it right there.
So we're going to change this into vertex form, not factored form. We're going to change it into vertex form. So I'm going to show you the strategy. Remember, the idea is to complete the square. So what I'm going to draw here is I'm going to line up my algebra tiles. We've got x squared plus 6x. And for now, I'm just going to leave my 5 off to the side. Okay? 1, 2, 3. Can you see them? No. 1. I want you to see them still, though. Okay. Right. So what are we missing here to complete the square?
X squared.
We are done with our x squared. We already have it.
It would fit.
We already have 6 x's.
Oh, you need
You
5.
need little ones.
So how many ones will it take to
6.
fill this square?
9.
Okay, good. It will take 9 ones to complete this square. So what I'm going to do is I'm going to add 9 ones to my equation so that I can complete the square. But if I add 9 ones, I've changed the value. So if I'm going to add 9 ones, I also have to subtract 9 ones. So here I can add my 9 ones. This is exactly what we're going to do using algebra soon. So I've got my 9 ones. No, it's not a mistake if the square is upside down.
Mine just use it as our x
And because I've added my 9 ones, I also need to subtract 9 ones. So I have some negative ones here. 1, 2,
Then what's the
3,
point of having 9?
4,
Yeah, now
5,
the easy is
6,
different.
7, 8, 9.
9, and you subtract
Okay?
9, it's gone.
So now I have a completed square. The nice thing about the completed square is that I'm now able to write this as a squared binomial. And outside of my bracket, I now can knock out some of these pluses and minuses. So they cancel out, they cancel out, they cancel out, they cancel out, and they cancel out. And I'm left with, after I have my perfect square, I'm left with minus 4 on the outside. Okay? So on the outside, we had minus 9 plus the 5 that we already had, which becomes minus 4. That is a quick demonstration on what we're doing. We're going to be given a quadratic expression in standard form. We're going to be thinking of the number that will allow us to complete the square, that will allow us to express the first 2 terms as a completed square. And then we're going to finish it off by finding out what happens to the number at the back. Okay? So step by step, we're completing the square. Here's your visualization. Now we're going to do a bunch of examples using algebra skills. So our goal in getting from standard form to factored form is called completing the square. So a definition for completing the square is a process for expressing y equals ax squared plus bx plus c in the form y equals ax minus h squared, that's our completed square, plus k. It involves changing the first 2 terms of the quadratic relation here. So we're going to be looking at the first 2 terms, and we're going to make them into a perfect square. Remember last unit we talked about what has to be true for a perfect square, but we need to also maintain the balance of the original relation. So we're going to be taking this, making these first 2 terms into a perfect square by adding and subtracting an integer, adding and subtracting 1s. But then we still need to make sure that we keep the right balance so that we don't change any of the information. So we don't change the equation itself, we just change the form that it's written in. Example 1, we're going to do some completing of the square. So we are going to rewrite y equals x squared plus 8x plus 5 in vertex form. So one method that we can use is algebra tiles. We can make the box and complete the square by adding and subtracting the right number of algebra tiles to complete the square. Or we can use some of the algebra that we learned last unit, and carry on from there. So very important. Here we go. I'm going to rewrite our equation. I notice right away that my a, the coefficient in front of x squared, is just 1. So this is a bit of an easier problem to start with. And when I rewrite it again, I'm going to group the first 2 terms. So I'm going to group my term with the x squared and my x term. Use a different color here. So step 1, group first 2 terms. So I'm going to group my first 2 terms here. And I know that I'm going to be completing the square. So inside this bracket, what's actually going to happen is I'm going to be adding or subtracting the right number, adding and subtracting the number that will complete the square. And I'm going to have plus 5 out here. Okay, so I haven't changed any information at all. I still have x squared plus 8x plus 5. Exactly the same as the equation that we were given in the beginning. Okay, but now I want to make a perfect square. So if you remember about perfect square trinomials, we had the pattern a squared plus 2ab plus b squared. So that tells me that if this is going to be a perfect square, where a is x, 8x here is going to be equivalent to 2ab. 2ab. I already know that a is x, so what does b have to be in order to get me to 8x? So I know that this is 2 times b times x. What does b have to be to get 8x? B has to be 4, because 2 times 4 times x is 8x. So all we've done really is taken half of your second term. Take half of the second term. So we're going to make, so step 1 is here, step 2 is here, make a perfect square trinomial by taking half of b and squaring it. So we make a perfect square trinomial by taking half of b and squaring it. So what we do is we take half of 8, which is 4, and we square it. So I add 16. But now, maybe I'll just rewrite the whole step. I'll write the whole step. So we have x squared plus 8x plus 16, and I still want to leave a little bit of space inside my bracket, plus 5. Because if I added 16, that's not really fair. Now I've changed the whole value. So now what do I have to do to balance it? Good. Balance.
So is that step below the step that we didn't finish yet?
It's all just nicely in order here. Balance the equation by subtracting 16. Still inside my bracket. So now I haven't actually changed the value of it at all. I still have x squared plus 8x plus 5. And this plus or minus 16 would just be 0, but I need that information because I needed to create a perfect square trinomial. Okay? So now what we're looking at here is this minus 16 can really just get kicked out of the bracket. It can just get moved out of the bracket because the invisible coefficient here is 1. So the value of this is just x squared, this is just 8x, this is just 16, and this is minus 16. So when I rewrite my perfect square trinomial, plus 16, I can put minus 16 on the outside of the bracket. So move negative 16 out to form perfect square trinomial. So we've now moved our 16 out to form a perfect square trinomial. And now I can represent this perfect square trinomial like we did last unit. I can represent this perfect square trinomial as a squared binomial. As a squared binomial. And the squared binomial that goes with this, if we're following our pattern, and I'll just leave the pattern. Well, maybe I'll write the pattern first. So the pattern here that we're given is a squared plus 2ab plus b squared. And if we remember from last unit, that means we can express this as a squared binomial, a plus b squared. So that's our last step for the bracket here. Express as a squared binomial. In this case, a is x, and b, we said, is 4, right? Because 4 squared is 16. So the square root of 16 is 4. And now it's expressed as a square binomial. Outside the brackets, we have negative 16 plus 5, which is minus 11. So our last thing that we did there is express our perfect square trinomial. I'm just going to say express the brackets as a squared binomial and combine terms outside of brackets. So there's our first go at completing the square. We're going to run through it really quickly and then do another example. So we've got our equation in standard form. We are going to group our first two terms, leave a little bit of space because you're going to be adding and subtracting the same value here in order to complete the square. This is our completing the square part. Then we can express that completed square as a squared binomial because we kicked this negative 16 out of the bracket, combined our terms outside the bracket to be minus 11, and now we know the vertex. The vertex is at negative 4, negative 11, because h is 4, negative 4, and k is negative 11. In example number 2, we need to find the maximum or minimum point of the parabola with the equation y equals 2x squared plus 12x plus 11. So right off the top, let's just decide, are we going to be finding a maximum or are we going to be finding a minimum? Think about it for a second. How do we know we're going to be finding a minimum? Okay, because the coefficient a is a positive, which means this parabola opens up, which means it's going to have a minimum point. We're going to follow the exact same steps that we did last time. So if you need to learn the steps over again, I'm not going to write them on the side this time, so if you need that kind of example, watch the previous part of this video. But we're going to do it without all those in-between steps, although I will make mention of them as we go. Now I notice in this one is different than the other one. What is special about this one?
There's an A.
There is a coefficient a that is not 1. So in the last example, the coefficient of the x squared term was just 1. In this example, it is 2. So we're going to need to deal with that. First step first, let's rewrite our equation and group our first two terms. We're going to group our first two terms. So we rewrite our equation by grouping our first two terms. Now it's difficult for us to complete the square if the coefficient a is not 1. So we want that coefficient to be 1. So what I can do here is I can actually take this, which is now a binomial, and I can factor out the coefficient. I don't want to factor the greatest common factor out, okay, because I still want an x squared term and an x term inside my bracket, but I can factor out the coefficient a. Okay, so that's the step we did not do in example 1. We will factor out a. So I have 2 outside of the bracket, which leaves me with x squared plus 6x. And now I'm going to leave a little bit of space inside my bracket and my plus 11 on the outside. Always easiest while we're learning this and getting better at it to leave that space inside the bracket to remind you that there's going to be something added and something subtracted from that bracket to balance it. Okay? Now, to make a perfect square trinomial, right, we need a perfect square trinomial in order to represent it as a squared binomial. So what do I need to do to make this bracket a perfect square trinomial? Remember, we need to take half of b and square it. So all you're doing is taking half of b and squaring it. So 3 squared. We're going to add 3 squared, and to maintain balance, we need to subtract 3 squared. Now, it's incredibly important that you remember to put both of these inside the bracket. Please look at what happens. This 3 squared actually has the value of 2 times 3 squared. If we think about our distributive property, the value of this is actually 18, not 9. So if we were to subtract 9 outside the bracket, we actually would have added 18 and only subtracted 9. So it's very important that they both stay inside the bracket for now, so that we represent the accurate value. We're actually adding 18 here, and we're subtracting 18, because the 2 is getting distributed to both of these terms.
So you subtract 18 for that spaces?
Well, we haven't done anything yet. We're going step by step. So now our next step is that I want the middle to be a perfect square trinomial. I already have that right here, but I have this extra thing. So how do I get this negative 9, this negative 3 squared, outside the bracket? How do I get it out of the bracket? I can't just move it over, because it has a value of 2 times that. So what I need to do to move it out of the bracket is I actually need to multiply it by 2. I'm going to distribute this 2 just to the last term right now. So we're distributing the 2 to the negative 9 so that I can put it outside the bracket. So the rest of it is going to stay the same. X squared plus 6x plus 3 squared. I'm going to close that bracket because I now have a completed square trinomial. And I've distributed the 2 to the negative 9 so that I can move it outside of the bracket. I now have negative 18 plus 11 outside of my bracket. So now I have both added 18, because I have 2 times 9, and I've subtracted 18. And the last step, I represent this completed square trinomial as a squared binomial, which is just a plus b squared. A is x, b is 3, square it, and I group my terms outside the bracket. Negative 18 plus 11 is negative 7. So now I have expressed my equation, which was given in standard form. I've expressed it in vertex form, and can somebody please give me the answer to the problem, which was find the max or the min. So our vertex is HK, right? Negative 3, negative 7. Therefore, we have a minimum, because we said it opens up. Minimum at negative 3, negative 7. In example 3, we're going to use our newly developed skills to work with a real-world problem. It's the path of a ball. So the path of the ball is modeled by the equation y equals negative x squared plus 2x plus 3, where x is the horizontal distance traveled by the ball, measured in meters, and y is the height in meters above the ground. So y is the height in meters above the ground. So y is our vertical height, distance, and x is our horizontal distance, and it is thrown from the top of a fence. Okay, so it's thrown from the top of a fence. And we have some questions. What is the maximum height of the ball? And at what horizontal distance does it occur? So we want to find the maximum height, which is going to be a y value, and then we want to find the x value where that maximum height happens. So really all we're doing here is finding the vertex of our parabola, because the vertex will tell us the maximum height, and it will tell us exactly at what point it reaches that maximum height. Then we're going to sketch a graph to represent the path of the ball. So I'm actually probably going to use this grid to sketch the graph after we've done this. Okay, so first, to find the maximum height of the ball, all I have to do is convert into vertex form. So I'm going to rewrite, and I'm going to group my first two terms. Negative x squared plus 2x plus 3. And I notice that the coefficient in this situation is not 1. So the coefficient a is not 1. What should I do? I want to factor out negative 1. The coefficient right now is negative 1. So I want to factor negative 1 out of both of my terms in the bracket. So I factor negative 1 out of this term, I end up with just x squared. And if I factor negative 1 out of this term, I just end up with the opposite, which is negative 2x. And at this point, I want to leave a space to complete the square. And I've got my plus 3 on the outside. Now to complete the square inside the bracket, we're going to take half of b. b is negative 2. So half of b is negative 1. And square it. Okay, so we're going to add this inside our bracket. So we've got negative 1 on the outside. X squared minus 2x inside. We're going to add negative 1 squared. And if we're going to add negative 1 squared, we need to also subtract negative 1 squared. And we still have plus 3 on the outside. Now for the completed square, all we need is our first 3 terms here. That will create a completed square trinomial, a perfect square trinomial. So how am I going to get this minus negative 1 squared outside of the bracket? It might be easier if we just rewrite it one more time.
Really confusing.
It's the exact same steps we did last time. We took half of our coefficient b, squared it, and now we're putting that in the bracket to complete the square. So we added this because we need to add it, and because we're adding it, in order to balance the equation, we also need to subtract it. So yes, this looks a little fuzzy right now. That's why we're rewriting it, because we know what negative 1 squared is. What's negative 1 times negative 1?
I mean 2. Sorry. 1.
Just 1. Negative 1 times negative 1 is positive 1. So here we have plus negative 1 squared, and we have minus 1 with a plus 3. Okay, so now it's a lot easier. We have our completed square trinomial, but I need to get this negative 1 outside of the bracket. How do I move this negative 1 outside of the bracket? Can we please continue paying attention? Thank you very much. I need to move this negative 1 outside of the bracket, but it isn't isolated. It's being multiplied by negative 1 right now. So in order to move it out of the bracket, I need to distribute the negative 1 to the negative 1. So negative 1 times negative 1 is positive 1. So now I'm left with a bracket of x squared minus 2x plus negative 1 squared. And I can have a positive 1 out here with my positive 3. The reason that we left this negative 1 squared in the little awkward brackets is because this tells us immediately a is x, because it's the square root of this term, and b is negative 1, because it's the square root of this term. Okay? If I rewrote this just right away as 1, I might lose in my mind the fact that it's actually not going to be x plus 1, it's going to be x minus 1 in my squared binomial. So it's better if you leave b squared like this, so that now we can quickly and easily write our squared binomial. X is a, minus 1 is b squared. Group our like terms here on the outside of the brackets is plus 4.
How'd you get the negative 1 in 1 part?
Because b is negative 1. So it's a plus b.
No, like in front of the bracket.
So right off the bat, we noticed that we did not have a coefficient of 1. We wanted a coefficient of 1, but we had a coefficient of negative 1. So we factored that out of both of these terms, which left us with x squared, which is a nice positive coefficient, minus 2x. Okay, so a little bit of a trickier one, but a good example for you to be able to refer back to when you're doing your homework. We now know the vertex. Vertex is at 1, 4. And our goal was to find the maximum height of the ball. So what is the maximum height that this ball reaches?
The vertex. 1, 4, 1, 4.
So the maximum height that the ball reaches is just the y coordinate.
4.
4 what?
Meters.
Meters. The maximum height is 4 meters. And at what vertical distance does it reach that height?
1.
1 meter. Way to go. Okay, so I'm going to use my vertex there at 1, 4 to sketch the graph. Your graph does not need to be perfect, okay? We'll say this is the point 1, 4. Vertex is at 1, 4. So here's 1, here's 4. I know from the standard equation that my y-intercept is plus 3. So I know it's being thrown from a height of plus 3, which is right here. And we can go ahead and draw our curve. Ideally, we would find another point on the curve to help us draw it. But we know we're going through this point, and we know it's going to be symmetrical.
Do you ever have a non-symmetrical parabola?
There is no such thing as a non-symmetrical parabola. I'm reminding you every time that that's why we can draw it as symmetrical. All right, we have found the maximum height. We found the horizontal distance that this occurs at is 1 meter, and we were able to draw a sketch of our parabola representing the ball traveling. Okay, example 4 is a real-world application of parabolas we've talked about before. It is a boy named Alex who runs a snowboard rental business, and he wants to find out what is the best price to rent his snowboards at in order to maximize revenue. So revenue is the money that comes into a business. Okay? Currently, Alex charges $12 per snowboard rental. So currently, $12 per rental, and he gets about 36 rentals per day. 36 rentals per day. He discovers that for each 50-cent decrease, so for each, and we're measuring in dollars, so we're going to write 50 cents as $0.50. For each 50-cent decrease in price, he rents out 2 additional snowboards per day. For each 50-cent decrease, he rents 2 more SBs, snowboards. At what price can Alex maximize his revenue? So this is a word problem like we had back in Unit 3, I believe, or 4, where we are given some information. We're given 2 factors. So we are going to represent this in factored form. Then in order to get our vertex, we need to go from factored form to standard form, which you know how to do, and then into vertex form. So we are going to start our problem. First step first, let's introduce some variables. Let R be revenue,
No, Amy, that's not me.
Yes, it is.
let x
I make that much.
Be-
Guys, shut up so we can get out of here.
the number of 50-cent decreases. So let R be revenue, let X be the number of 50-cent decreases. Well, that gives us two factors for revenue. Revenue is just the price that something is sold at times the number of things sold, right? So he's the price of his rental times the number of rentals. So we want the new formula for revenue. He's starting at $12 and he's going to decrease the price by half a dollar, 0.5 by every price reduction. So the new price is however many price reductions he did subtracted from the $12 original rental price. And his new number of rentals per day is 36 plus 2x. He has 36 currently, and for every price reduction, for every x, he's going to get 2 more. Okay, so here is our equation in factored form. So first what we need to do is expand this into standard form, and then we're going to complete the square, and I'm going to go fairly quickly. To convert it into standard form, that's just the distributive property. It's foiling, okay? So we have 12 times 36, which is 432. Then we have 12 times positive 2x, which is 24x. Then we have our inner terms, which is negative a half x times 36, which is negative 18x. And our two outer terms, which is negative times a positive, and it's a half times 2, which is 1, and it's x times x, which is x squared. So it's just negative x squared. At this point, you want to rearrange it and group your middle terms. So we have negative x squared, and then in the middle we have plus 24x minus 18x, which is plus 6x, and at the end we have plus 432. So here's our equation. It's in standard form. Standard form. I am going to erase it, otherwise I'm going to run out of space, and I'm going to rewrite it closer to the top of my page. So we've got negative x squared plus 6x plus 432. And now I need to complete the square. First step to completing the square, group our first two terms and factor out the negative 1 so that we have a coefficient of 1. So we have negative 1, and in the brackets we have x squared minus 6x. Notice how that changed the sign of my 6x term. I'm going to leave some space inside the bracket. We have plus 432 on the outside still. Now in order to complete the square, I need to find out what I'm adding and subtracting here in order to have a perfect square trinomial. All I have to do is take half of b and square it. Half of b and square it. So half of b is negative 3. Squared is negative 3 squared. So I've got negative 1 x squared minus 6x it's going to be plus negative 3 squared, okay, which is plus 9. And if I'm adding 9, I need also to subtract 9. Okay? 432 on the outside of the bracket. Now I have a completed square trinomial here, but I need to get rid of this negative 9 first. So I multiply it by negative 1 to kick it out of the bracket. X squared minus 6x plus 9 plus 9 plus 432. Now I can rewrite my perfect square trinomial as a squared binomial. That's x minus 3 squared. And I can group my terms at the end here. That's 441. We now have this in vertex form. Okay, we have this in vertex form. Therefore, my vertex is at 3,441.
That's high.
And the question that we needed to ask was, at what price can Alex maximize his revenue?
441.
No, his maximum revenue is going to be $441 per day, but that doesn't tell us what price he should rent them out at. We have x equals 3. So we have 3 price reductions. 3 price reductions.
Really scared there.
No, why can't I get white out?
3 price reductions of 50 cents. Okay? So the price is 12 minus 1.5, which equals $10.50. Therefore, Alex should reduce his rental costs to $10.50 in order to maximize his revenue. Thank you very much for paying attention. Please don't leave without your homework. Your homework is page 234, number 1 through 9. 234, number 1 through 9. And if there are lots like ABC, just do A, C, E, G, etc.
Okay, let's try.
Have a good day.